Okay everyone, here is this week's lesson. We're going to be learning about what's inside the atom. Okay, our learning intention for today was to learn what is located inside an atom, and then by the end of today you should be able to name the 3 small particles located inside an atom. You should be able to tell me the charge on them, so are they positive, do they have a negative charge, or do they have no charge at all? You should be able to tell me their location, so where you could find them inside an atom, and then we're going to start to build our own atom using some of the options in your OneNote this week. There's a bit of software there you could use. If that's not working, then you can maybe build your own with materials you have in the house. Now let's look at a gold bar. We all know what gold is. We all have gold jewellery, some of us. It could be gold, could be silver. If we were to magnify in on that gold bar, what would it look like? Magnify thousands and thousands of times down to a level where the eye cannot see. What you would see is these little atoms here, nice neat rows, nicely packed together, and all elements in the periodic table are made of these small particles, and these are called atoms. Okay, now here's a picture of a very early periodic table with these very complicated symbols. I cannot even understand what that means, no idea what elements are which. That's why more recently we have this. This is our periodic table here. We've all seen that on the wall in the most science labs. You see hydrogen up here. It's the first element in the periodic table. It's got a little 1 there. That means it's the first. Helium is the second. Lithium, beryllium 4, boron 5, 6, and so on. They're all in order. They're all in nice columns going along the way, and they're also in nice neat rows as well. Now these numbers that I've just highlighted there, hydrogen 1, helium 2, they're going to be quite important, and we're going to be looking at these later on. Now there are some elements that are named after people. Curium is one of them. That's named after Marie Curie, who won a Nobel Prize. Alfred Nobel, Nobelium. Mendelevium, he was the man who came up with the first periodic table and put all the elements in nice neat rows and columns. And I'm pretty sure we all know who Einstein is. Can you see that all these elements have an atomic number that is always different? That's like their fingerprint, their atomic number, 96, 101, 99, 102. Here are some elements named after countries. So germanium, named after Germany, francium, named after France, and polonium for Poland. Again, they all have different atomic numbers. So polonium 84 is the 84th element in the periodic table. There are some elements named after planets. So Mercury, uranium, Uranus, Neptunium, named after Neptune, plutonium. Obviously Pluto is a dwarf planet now. Krypton, any Superman fans in the house? And you're probably thinking tellurium is not named after a country, but the Latin word for earth is based on the word tellurium, so that's where that one comes from. And again, they all have different atomic numbers. That is their fingerprint. So back to atoms. If we were to magnify even further, what would be inside an individual atom? Let's have a look. We have these 3 things here. We have a thing called an electron. We're going to try and keep that in green. Can you see it has a negative inside it? So that's its charge. So negative electron. Protons are positively charged. We'll keep them in blue. And a thing called the neutron. The word neutron means no charge. So back to our success criteria, we had to remember the three things that are located inside an atom. There they are there. We had to name them, and we had to find out the charge on them. So they're all in that picture there. Electron's negative, proton's positive, and a neutron has no charge. Now we're going to find out where they are located. So I'll just go back here. This bit in the very centre, where the protons and neutrons are, we call that the nucleus. That's the very centre of an atom. Only protons and neutrons are found in there, nothing else. Electrons are located in these outer two rings here, and we don't call them rings. From now on we're going to call them shells, the electron shells. That's where the electrons are found. So we've actually ticked off quite a few things already for the success criteria. We've went over the name, we've went over their charge, and we've went over their location, where they can be found. So next, I want you to pause this video, copy this diagram and this table, and I want you to be able to complete that and post a picture into your OneNote. So what is the charge on an electron, neutron and proton? It can either be positive, negative or no charge. And where are each of these three found? So is it in the nucleus? Is it in the centre maybe? Or is it in shells? And in the diagram at the top, I want you to name this particle here that's found in the ring on the outside. You'll write that in there. And this is here is another name for the centre, the fancy name for the centre of an atom. And what is the name of the two particles that are found in the centre? You should be able to do that easy enough, and then post a picture in your OneNote, please. Now let's go back to atomic number. I've already described that each element has its own atomic number, and it's like its own fingerprint, and it gives us information about that. So nitrogen has got the symbol N. It's the 7th element in the periodic table, and what that tells us is that it has 7 protons. Magnesium has got the symbol Mg. It's the 12th element in the periodic table, and that tells us it has 12 protons. Carbon is the 6th element in the periodic table. 6 protons. You see a trend here? The atomic number tells us how many protons something has. That's what we have at the bottom here. Right. Next, I want you to pause this video and look at the periodic table, which there's a link in your OneNote, and I want you to tell me how many protons each of these elements have. Right, pause the video right now and do this as a little task. Okay, did you all manage to get the answers for these? Right, chlorine is the 17th element in the periodic table, therefore it has 17 protons. Potassium is the 19th element in the periodic table, therefore it has 19. Hydrogen is the very first element in the periodic table, therefore it has 1 proton. Now remember, protons are positively charged. Now if I was to tell you that all elements in the periodic table are neutral overall, then if chlorine has 17 positive charges, it also must have 17 negative charges. So chlorine must have 17 electrons, because remember they're negatively charged. So if you have 17 and then your take away 17 leaves you with nothing, so it's neutral overall. Potassium, again, because it's neutral, it must have 19 electrons as well, because it's 19 take away 19. And hydrogen, it's got one proton, therefore it must have one electron, one negative charge, 1 minus 1 equals 0. So that is why all elements are neutral overall, because they have the same amount of protons and electrons. Go over some consolidation questions here. Again, pause the video and have a go at these. Right, how did you get on with these? What information does the atomic number tell us about an atom? It tells us the number of protons an element has. Why are atoms neutral overall? Remember, they have the same number of protons, which are positively charged, and the same number of electrons, which are negatively charged, so they always cancel each other out. And the last question, where are the electrons found? They're found in the rings on the outside, and the other name for the rings is the shells. How did you get on with those? Mark yourself out of 3. Now, atomic number and mass number. We've covered atomic number. Let's go over something called the mass number. Now, you might see this kind of setup here, like these two here. So this gives us, this is the symbol for an element. This bottom number here is the atomic number. We've already done that. Atomic number. That tells us how many protons it has. So it has 20 protons, and it also has 20 electrons because they cancel each other out. This is symbol for Ca is calcium. We all need calcium for strong teeth and bones. This number at the top is the mass number. That's how much it weighs. And that tells us in the nucleus how many protons plus neutrons there are. Not looked at the word neutron since the very start. So that's protons plus neutrons. So if we were to take these two numbers away, so for calcium, the 40 take away the 20, because that's protons plus neutrons, and that's protons only, if we take those two numbers away, that will give us the number of neutrons that we have. So therefore we have 20 neutrons. Now let's look at this second example. The symbol C, that's carbon. The bottom number tells us it's protons and electrons. So protons equals 6. Neutrons equals 6. Electrons equals 6. 12 is the mass number. So that's protons plus neutrons. So if we do the 12, take away the 6, that tells us that it also has 6 neutrons. 6 protons, 6 neutrons, 6 electrons. Just be careful, it will not always be 6, 6, 6, 20, 20, 20. There are some elements where that number will not always be the same number for the 3. Just be careful with that. I'll give you a quick example. Potassium has got the symbol K, and it has these two numbers here, 19 and 39. So it has 19 protons, 19 electrons, and then 30 with 9 take away 19 is 20 neutrons. So just be careful, they're not always the same number. Okay. Right, that's the last slide. Now you can go to your OneNote and answer the questions. Good luck.